Hello guys, so in this video we are going to discuss about slope, okay? The main reason why we are understanding about slope is that because in this series of videos we are going to understand about a very core topic which is called as derivative. And this is really important for data science to understand machine learning algorithms and all. So first of all, we'll go ahead and understand about slopes and then in the series of video we'll also be understanding about derivatives, okay? And I hope you have heard about this slope even in your high school days, right? But our main aim will be basically to understand with respect to the application in data science industries, okay? So first of all, we'll go ahead with the definition. A slope of a line is a measure of how steep the line is, and it represents the rate of change of one variable with respect to another variable, okay? In the context of two-dimensional Cartesian coordinate system, the slope indicates the ratio of vertical change, that we say it as rise, to the horizontal change, that we say it as run, okay, between 2 points on a line. Now, in order to understand, let's consider that I have a coordinate system over here. And let's say I have a specific line, okay? So this is my line, okay? Now, since this is a straight line, right? Let's say there are two, or if I probably say this as a straight line, I really want to understand what is the slope of this line. Now, what do the slope actually mean in this context? If I say, hey, this is my x and y coordinate, let's consider that I'm going to consider two coordinates over here, right? So this is my coordinate of x1, y1, and this is my coordinate of x2, y2, okay? Now, slope basically means is that what is the rate of change with respect to one variable with respect to another? Or I can also say, what is the rate of change of one variable with respect to another? So let's say if I move my x-axis over here, let's say this is 1 unit or this may be 2 unit. If I'm moving by this many number of units towards the x-axis, how much unit we are basically moving towards the y-axis? And this exact change, this is also called as a rate of change. Rate of change. This rate of change is specifically determined as slope. So this line that you're able to see is nothing but it is basically talking about the slope. Okay. Now, again, let me go ahead and show you in terms of formula. Okay. So usually slopes, if we really want to calculate slope, we basically say what is the rate of change of one variable with respect to the another one, right? So here you can see this coordinate is x1, y1, and this coordinate is x2, y2. Now, in order to calculate the slope, I have to first of all see what is the rate of change of one variable. So first of all, let's see that I'm actually trying to consider how much y has actually changed, right? So y has changed from here to here, right? So it was initially y1 over here, and this is my new y2, okay? So when I say the rate of change, this is nothing but y2 minus y1. This is how it is basically given. We are trying to find out how much y coordinate has actually moved. Similarly, we will go ahead and divide this by x coordinate, right? x2 minus x1. This can also be specified as delta y by delta x. Delta y basically means the rate of change with respect to y variable, and this is nothing but the rate of change with respect to x variable, okay? And usually the delta y is basically called as rise, right? Rise. Why rise? Because this is moving above, right? In the y direction. Similarly, in the horizontal change, we basically say it as run, right? So this slope can basically be calculated by this delta y divided by delta x, which is nothing but rise by run. Now, this is with respect to the slope, right? And this is with respect to the a coordinate system with 2 dimensions. If you have 3 dimensions, then you know that you'll be having 3 coordinates. And similarly, you can go ahead and subtract that. And with respect to every coordinate, you'll be able to subtract it and you'll be getting a 3-dimension point, right? So this is how you basically go ahead and calculate the slope. So here, let me just go ahead and write where on this equation, y2 minus y1 is the vertical rise and x2 minus x1 is the horizontal run, right? Because this is moving in the horizontal direction, right? So here are the two terms, that is rise and run, okay? Now we need to understand what is the interpretation of this particular slope, right? why do we specifically go ahead and see the rate of change? Let's say that I have a data set. Now in this data set, let's consider that I have two features. Okay. The one feature is the area of the house, and the other feature is basically called as price. Okay. Now in this area and price, let's say that when I'm plotting with respect to all my data points is coming in the form of a straight line. Usually this does not happen in a real world scenario, because in a real world scenario, you will not always get a straight line, right? You will be also getting a non-linear line. The non-linear line can be in any direction like this. Okay. It can be. So we'll discuss about this more as we go ahead. But let's say that this is my area and this is my price, right? Now, as the area keeps on increasing, you will also be seeing that the price is also increasing, right? Now, I really want to understand that what is the rate of change with every unit movement with respect to area. So let's say that these are my two coordinates. Let's say from x1 to x2, if I go, right? So what is the specific change? And with respect to this, when I am changing the area, how much y value is basically changing. If my y is over here, how much it is basically changing. So this is basically the rate of change that we are talking about. Okay. And this information we really need to have it, because if we have this specific information, definitely it becomes very much important for machine learning algorithms, because through this they'll be able to understand the relationship between all the features itself. And at the end of the day, whichever machine learning algorithms we try to solve, this information will also get captured over there. Now, till now it is fine, we have understood over here. Now let's discuss about some of the very important properties of this straight line and when we are calculating the slope of this particular line. Since the line is completely straight, so here you'll be able to see that the rate of change with respect to any points that you probably take. Let's say that if I'm taking 1 point over here, 1 point over here, or the other point over here, other point over here, the rate of change, right? Specifically, if I consider, it will be same. It will be same or it will be constant, right? It will be same or it will be constant. Here you can clearly see that because it is a straight line. So with respect to every unit that I check, right, what is the rate of change? It is going to be almost similar, right? So here also it will be same, here also it will be same, because this is a complete straight line. Now, what if instead of this particular straight line, I had a different kind of curve? Let's say I had a curve which looks like this. If I had a non-linear curve, right? So this is basically a non-linear curve. Now in this scenario here, you can see that my rate of change specifically may be different over here. My rate of change may be different over here. My rate of change will be higher over here, because as we move towards the x-axis, the y-axis value is increasing more, right? So usually in a straight line, the rate of change, the average rate of change is going to become same or it is going to be constant with respect to any data points that we probably consider. And this we are considering in terms of units. Okay. Now the interpretation of slope also needs to be done. And before that, what I will do is that, okay, let's go ahead and write one very important thing, which is called as interpretation of the slopes. Interpretation of slopes. What are the key important information that we get? See, the first information is something called as positive slope. Now, if my slope that I calculate is greater than 0, you can also say if it is greater than 0, that basically means the line rises as it moves from left to right, right? So if the line is moving from left to right, you'll be able to see that once we calculate the slope value will be coming as greater than 0. Okay. So here I can also write one condition: the larger the slope, the steeper the line. The steeper the line. Okay, so this is a very important property with respect to positive slope. Don't worry if you get some idea. What we are doing is that whenever we calculate slope, if the value is greater than 0, we basically say it as positive slope. And in order to determine positive slope, there will be a feature wherein the line rises as it moves from left to right. So remember this particular point. Okay. Now coming to the second most important interpretation over here, and that is nothing but negative slope. Since there is a positive slope, obviously there is also going to be a negative slope. Now, when do we get a negative slope? If the slope is less than 0, right? And here the line, instead of rising, it falls. It falls as it moves from left to right. Left to right. Just to give you a basic example, for the first one, the positive slope will have a graph which will look in this way, right? The line is rising from left to right, right? In the case of negative slope, you'll be able to see that this will be in the reverse direction. So if I probably go ahead and draw this graph, it will be in this direction. So if I'm having in this specific direction, you know that the line is falling as it moves from left to right, right? So here you're basically going to get, when we calculate a slope, we are going to get a negative value. Okay. Here, let me go ahead and write one more point. The steeper the line, the steeper, oh, sorry, I can just go ahead and change this instead of writing like this. The more negative the slope, the steeper the line, in the downward direction. Okay. Now this is basically called as a negative slope. Here your slope will be less than 0. Okay. Now let's go to the third interpretation, which is also called as zero slope. And this is really important. You need to understand about the zero slope also. If my slope is equal to 0, that basically means the line is horizontal. Okay. The line is horizontal, meaning there is no vertical change. There is no vertical change as the line moves from left to right. As the line moves from left to right. This is important. Okay. Now, when we say zero slope, that basically means I will be having a graph like this. If this is my x and y coordinate, I will have a straight line. Right now, in this scenario, you'll be able to see that, right? If this is my one coordinate, x1, y1, and this is my another coordinate, x2, y2. Now, in this scenario, you don't have any change, right? There is no change itself. Initially, also, you had this specific value of y. For this x1, for x2 also, you have the same value of y. So here, the slope is going to be 0. Now, whenever we have a slope as 0, that basically means the line is horizontal. There is no vertical change with respect to that. Okay. And let me also talk about one more property or one more interpretation, which is called as undefined slope. Undefined slope. Now, in undefined slope, if let's say my two coordinates of x, right? If x2 is equal to x1, right? Let's say this is my x1, this is my x2. If x2 is equal to x1, that basically means the line is just going to be vertical, right? The line is going to be vertical. And here, if I have a line which is just vertical, so here I have my x1 and x2. So let's say this is my point, which is representing x1 also, which is representing x2 also. Now for this, you'll be able to see that in this scenario, I will be getting this, right? And this will be y. Let's consider this is y. In this case, my line is exactly vertical. And here, the slope, in this scenario, the slope will be undefined, right? Because you cannot divide by 0, right? Why it is come as 0? Because understand the formula of slope. y2 minus y1 divided by x2 minus x1. When we do x2 minus x1, it is going to be 0, right? So here, you cannot divide by 0, right? So this is basically called as undefined slope. So in this video, we have understood what exactly slope is. but we can just say that, hey, it is a rate of change of one variable with respect to the another. How do we calculate it? With respect to, like, if I say two coordinates, if I consider two coordinates, and then if I go ahead and see the rate of movement with respect to one variable, or rate of change in one variable with respect to the x-axis, and then how much rate of change is basically happening in the y-axis, right? So one more important scenario is that more steeper, if the line is more steeper, the slope will be higher. If the line is less steeper, the slope will be less, right? So that one important information that you have got. And with respect to this, you have also got the interpretation of slopes. Now let's go ahead and do some examples, and let's go ahead and calculate the slopes. Okay. So first example, let's say that I have a coordinate system. In this coordinate system, let's say I have a line which looks like this. Let's consider one of the point is nothing but over here, 1, 2. Okay. And the other point is nothing but, let's consider 3, 6. Now, how do I find out what is the slope, right? What is the slope between these 2 points, right? Now, between these 2 points, if I really want to calculate the slope, it will be nothing but, what is my y2? Y2 is nothing but 6. 6 minus 2 divided by 3 minus 1. This is nothing but 4 divided by 2, which is 2. Now, what does this slope indicate? Slope indicates that this means, this is my x and y coordinate. This means that for every 1 unit you move horizontally from left to right, right? Left to right. Let me just go ahead and write this, from left to right, the line moves 2 units vertically up, right? This is the information that I'm able to get it out, right? So here, when I say slope is equal to 2, that basically means if I consider any point with just 1 unit movement in the x-axis, there is a 2 unit movement in the y-axis. Just to probably consider, or in this scenario, if this is my 1 unit of movement, then I'm basically going to move 2 units. I cannot say this as 1 unit because this is 1, 3, right? So what will happen if this is 1, if x is equal to 2, you'll be able to see that I will be getting my new y value as 4. So this is nothing but 2, 4, right? This is what specifically it is saying. This means for every 1 unit you move horizontally from left to right, the line moves 2 unit vertically up because I've got the slope as 2. Okay. Let's take another example, and this example will be specifically for negative slope. A negative slope. Let's consider that I have 2 coordinates in a line. That is nothing but 2, 5, 6, 3. Now, if I want to calculate the slope, it will be nothing but 6 minus 5 divided by 3. Sorry, my y2 is 3, right? So my y2 is nothing but 3. So 3 minus 5 divided by 6 minus 2. So this is nothing but minus 2 by 4. So once I calculate this slope, let's also try to plot this. Okay, so let's plot it over here. So here is my plotting. So what I'm actually going to do is that the first coordinate is 2, 5. Let's consider this is 1, 2, 3, 4, 5. This is 1, 2, 3, 4, 5, 6. Okay. So 2, 5 basically is nothing but, let's say this is the point 2, 5. Okay. Right. This is 2, 5. And when I say the next coordinate, that is 6, 3. 1, 2, 3, 4, 5, 6. Let's say 6 is this coordinate. 3 is somewhere 1, 2, 3, somewhere over here. Okay. I will just go ahead and plot it. Now in this important diagram, you can actually see that if I try to plot this, right, you'll be able to see that as we go towards the horizontal x direction, the line is coming down, right? Before, in the case of positive slope, the line usually goes up, right? So this is my coordinate, that is 2, 5, and that is basically 6, 3. Okay. Now, what does this basically indicate is that when I go ahead and calculate the slope as half, right? So here you can clearly see that with respect to any unit movement with respect to the x-axis, the direction by which it is basically coming down, it is nothing but, or the value that is vertically coming down is by half units. Okay, so this is the understanding that you can specifically come up with. One more important way that we can basically mention, because it is not good to always say in fraction like half. Here I can go ahead and write, this means that for every 2 units, you move horizontally. Okay, you move horizontally to the right. So if I'm taking 2 unit move, if I'm moving towards the right, before if I'm moving 1 towards the right, we were basically the vertical direction was coming down by half unit. But when I made it 2, that basically means the vertical direction will probably be by 1 unit, right? So I can go ahead and write, the line moves 1 unit vertically down, right? So this is what we can probably come up with, right? So I hope you have got an idea with respect to the negative slope, and this is what is the direction with respect to the negative slope. When your line is coming like this, if you go ahead and calculate the slope, then you'll be able to see that, hey, you're going to get a negative values. Now coming to the third one, which is called as zero slope. Zero slope. Now in the case of zero slope, consider the points. Let's say the point is 1, 4 and 5, 4. So if I have these 2 coordinates, if I go ahead and just plot this, let's say this is my plotting that I'm actually going to do. This is 1, 2, 3, 4, 5, 1, 2, 3, 4. 1, 4 means where? 1 and 4. Let's say this is my point. Okay. Then 5, 4, 1, 2, 3, 4, 5, 5, 4, same thing. Now just imagine if this is my entire line, if I just go ahead and compute the slope, what I'm actually going to get? Slope is equal to, first of all, I will take 4 minus 4 divided by 5 minus 1. This is nothing but 0 by 4, right? So in this particular scenario, what I'm actually going to get? The slope is basically 0. This indicates what? This indicates that there is no rate of change. This means line is exactly horizontal, and even though we increase by any units in x-axis, there is no movement in the y-axis, right? So this means the line is horizontal, right? And one important information in data science also, we can say, hey, this feature is not at all important because it is nowhere related to y, right? I'll not say not equal to y. Here I can definitely say it is not related to y, right? Not related to y. So if this is my output feature, this is not at all playing any important role in order to predict the output feature, right? Something like this. So this means the line is horizontal. Now similarly, I can go ahead and probably talk about the undefined slope. Undefined slope, right? The fourth one. In the case of undefined slope, let's take 2 coordinates, 3 by 2 and 3, 7. You can go ahead and plot this. If I go ahead and calculate my slope, it is nothing but 7 minus 2 divided by 3 minus 3, which is nothing but 5 by 0. If 5 by 0 is there, right, that basically means it is undefined, right? Because this output, what it is going to come, it is going to come as infinity, right? So it indicates just a vertical line. That's it. Okay. Because it will be in one point itself and it just indicates a vertical line, right? Now, this is what it was all about, where we discussed about specific slopes. And where exactly this will be used in one, like let's consider one example, right? Slope in a equation of a line, right? And I hope I've covered this already, right? Y is equal to mx plus b, right? So we basically say this is the equation of a straight line. Okay, equation of a straight line. And here specifically this m is the slope of the line. M is the slope of the line. Let's say if I have a line which looks like this, and this line passes through the origin 0. If it passes to the origin 0, that basically means this actually becomes y is equal to mx plus b. B is nothing but it is an intercept. It says that, hey, where we are meeting on the y-axis, if you are meeting on the origin on the y-axis at the origin, then that basically becomes b will be equal to 0, right? If this line meets at the origin at the y-axis, right? B just indicates that, hey, where we are meeting at the y-axis, that's it, right? M is nothing but slope, right? And here the second point that I will write it down so that you will be able to remember, B is the y-intercept, where the line crosses the y-axis, y-axis. Okay. Now, let's say if the slope is m is equal to 2 and the intercept b is equal to -3, then the equation of the line can be written as y is equal to 2x minus 3, right? So this is how we can basically write, and we can even construct our how in the coordinate system our line should look like. Since we are saying, hey, it should probably start with 3, right? So let's consider this is -1, -2, -3. So my line will probably come like this. Probably come like this, something like this. Okay. So just for an understanding, I've explained you, but already we have discussed about this concept, right? So let's say if I'm drawing like this, it looks something like this, since it is passing from y is equal to 3. And we can probably, with respect to different x value, we can go ahead and calculate it, and we can probably project this entire line, right? This was about slope, but as I told you, right, the most important thing will be that for a straight line, slope can be calculated in a very much easy way. But what about a line which will be in a curve, right? And this is basically called as non-linear line. Now, in this kind of scenario, the rate of change will not be same, right? Over here, the rate of change will be less. Over here, the rate of change will be more. Here, it can be much more, because here you can see it is still steep. As I said already, right? As the steepness increases, the slope also increases. As the steepness decreases, the slope may also decrease. Here, my steepness is coming down. Here, the slope is negative, right? In the case of straight line, it will always going to be constant with respect to the units. And that is what I'm actually going to discuss in the next video. And that is where we will also try to understand about derivative and limits. So yes, this was it from my side. I will see you all in the next video.